Hello and welcome. My name is Ravi Sundaram, and I'm responsible for the Kairos platform and business. Today, we also have Diego, who's our guest from Forrester. Just to introduce Diego, he is a vice president and principal analyst at Forrester, and he's been with the firm from, I think, July 2005. Now, first off, welcome, Diego. We're extremely pleased that you're here with us to discuss this very important topic. Just some more information about Diego. He's a trusted advisor. He focuses on very essential areas like application development and delivery, agile development, agile testing practices and tools. He also looks at DevOps, software testing and quality. And of course, he covers a variety of metrics from an AI standpoint as well. Now, with that introduction, we obviously have a very important topic to discuss today. The topic is TuringBots and whether these TuringBots are up for the AI autonomous testing challenge. Our belief is yes, and initially Diego will speak to that. But Diego and I will be sort of discussing this for about 40 minutes, and he will start by providing a definition of what TuringBots are, its value from a testing perspective, his market observations, market adoption, and some other related points. In the second half of our conversation, I will present an anonymized case study, sort of modeled after banking flows. So this will demonstrate where the technology is today, how it can be implemented and used for various personas, and most of all, how it can directly impact cost and value of testing. So that's the broad idea. So again, in quick summary, a quick summary would be Diego is going to talk about the market and what he sees from a TuringBot standpoint, and I'll present a couple of case studies to tie it all together. Right? Hopefully this is useful information for the audience. And with that, Diego, so we get started.
Thank you very much, Ravi, for the introduction. I'm delighted to be on this webinar with you. It's always fun. Our joint webinars have always been a great success. So let's see if we can repeat ourselves today. All right, so let me share screen. And so basically, as Ravi said, one area that I've been digging quite deep in Forrester about is artificial intelligence, the intersection of artificial intelligence with software development and applications. And I started actually doing research in this space in 2016. So cutting it short, I'm not going to discuss the whole roadmap what happened between 2016 and today. But I guess what everybody is aware of, what happened in the last year is what has matured us to speak and do much more research around the topic of AI in software development and testing. And that's an area we call TuringBots. So the point is that every organization that wants to succeed in a digital business transformation or acceleration is an organization that primarily uses software as their expression, as the primary expression of their business. So in other words, the more software is representing the key processes, policies, procedures of the organization, the more digital that organization will be. Now, we did a study together with Quinox recently involving 343 business and IT decision makers in the area a bit more broader than just software testing and AI, but in the area of digital transformation. And the data shows, when we interviewed those people, we asked them a bunch of questions. And when we asked them what are the top three key organizational challenges, legacy systems basically slowing down any type of modernization, organizational silos that don't allow the type of collaboration and dynamic teams collaboration that we need for an organization to thrive in digital, and also lack of DevOps transformation skills, agile transformation skills. So in other words, the transformation of modern software development itself. But they also are slowly adopting. I mean, this is happening, but it's still kind of, given the data we got back, slow. Some foundational elements are areas where they still need to improve. Things like in terms of adoption, right? Containers, continuous delivery, cloud native development. These are all foundational, really foundational technologies, and that require practices and change. So what we're seeing is, at the end of the day, while it is important and strategic for any organization to, in order to succeed with the concept of software is the expression of their business, right? It also, that translates into being able and having the capability to build, customize, and manage software very effectively, right? So in order to support that strategy of making software more and more the expression of business, it requires that companies become really fluent and effective in making change to a piece of software, instead of having to wait a day, a week, or a month, or being able to move quickly from from an existing architecture to another one. Think about the transforming towards going and moving to the cloud, for example. It's still an heroic effort for any organization that wants to go from a traditional on-prem to the cloud, to a cloud native architecture. But it shouldn't be that way. This should be, we should be able to do all this much faster. And so, but all that, really, the point, that we're making is that all that is about to really change, and it's about to change with generative AI, right? With generative AI and TuringBots. And the question is then, let me answer the primary question you might have in a minute on what TuringBots are. But before we go there, we also, and you might have read the abstract of this webinar, which talks about Forrester prediction of 10%, of a 10% statement that I made. I wrote that prediction myself, of worldwide code would be generated by TuringBots. That was a report written in basically September 2022 for 2023. Now, ChatGPT and generative AI hadn't exploded in our face the way it did 2 months later, right? We knew that it was technology in the labs, but nothing like what we saw happening at the beginning of 2024. And so let me say that this 10% number that I put here, after the event of ChatGPT, OpenAI, generative AI, becoming a real important thing in the market, it's a very cautious number. In other words, I think it's much more than 10% this year of software that is being generated with TuringBots, and also going forward. Actually, if you look at what generative AI, if you look at the data in our research, you'll see that in general, as a use case, using generative AI in the software application development is one of the top 3 most important use cases for enterprise clients, right? And besides that, we see now and know that there are millions, literally millions, and I'm not exaggerating, of developers that are using basically tools that are infused with generative AI to build applications, tools that today we see very popular in the development space, like code generation tools, right? Replit has over 21 million developers. Microsoft GitHub Copilot has over 1.2, 1.3 million developers using the tool. And so you can see hundreds of thousands, with AWS and Google, who are also catching up in that race. And so, but really what we see is that generative AI is not just for code generation, but it actually cuts across and supports the entire software development lifecycle, from ideation to coding, to test, to documentation, to deployment. And actually, that's exactly the heart of the research that I've been doing on, well, what is it really that this generative AI can do across the software development lifecycle, and not just. And so that brings me to this very simple definition. What are TuringBots? Well, by now, I think you've already kind of got the idea that TuringBots are like, AI agents or AI assistants, AI and generative AI assistants that support developers, testers, and development teams in building better software faster. So you can see how this relates directly to the original statement and message around software is a core expression of business for any, in a strategic way, for any organization that is really, trying to transform and accelerate their digital presence in the market. Let me go a little bit deeper, right? So basically what I'm saying is that we're going to have, and we have already, right? These are little ecosystems with tools behind these and vendors, a Turing bot that will support during the analysis and ideation and planning phase, a Turing bot that will support in design, mock-up, wireframing, and the design stage, let's say, right? Turing bots that will help us in the build of software coding, unit test generation. A tester Turing bot that actually does improve in a smart way the way we test. And last but not least, the delivered Turing bot that is there to kind of support the automation of what is built to help bring that into production and manage it in production. And actually, that is not the last Turing bot, because we've got one more, which we call the Dev Insights Turing bot, which is kind of the Uber Turing bot that leverages data that is generated throughout the entire life cycle. And you can think of in a continuous delivery pipeline how much data we generate during the development process, be it log files, be it bugs, be it tests that pass or tests that don't pass, and other data requirements and test cases and tons of data that is generated during the building of the software, from which we can turn that data, the Turing bot turns that data into insights for the whole team, for the quality and the state of the application perhaps, but also in terms of providing feedback for improving the way the product is being built. So to mention a few more to mention some use cases of these Turing bots, what the Analyze and Plan Turing bot can do is can help write and optimize requirements. It can help plan a better product landscape project. It can help improve the collaboration between the different stakeholders, because it can connect the dots, and you can ask it questions that today would require you to go through tons of files, opening files, and maybe chats, and to find out maybe where and who is the author of certain the impact of changing a certain requirement. What impact would that have on the rest of the process? The design Turing bot can help actually animate design. So design becomes something completely different with generative AI, because now you can really kind of and I'm just as an example, you can draw a web page on a piece of paper with buttons, with fields, and describing the fields, and describing literally with your pencil on a piece of paper what you want that page to look like and what you want it to do. And GPT-4 can read that and generate the entire web page, the code with the web page, to actually exercise that design. But even more than that, it can do things. You can have a Turing bot that will help you go from requirements to perhaps what's the set and architecture at a microservice level. How do I design the microservices to meet those requirements? And there are, of course, tools and technologies that we're starting to see in the market in that area. The generation of code, right? This is probably the Turing bot that today, together with testing, is becoming more and more popular because of ChatGPT. By the way, ChatGPT can also do the design. ChatGPT can also help optimize requirements. So there are some of these Turing bots that cut across more than one step. But the Coder Turing bot are specifically that functionality of generation, of code generation, of documenting code, right? Of translating one programming language, one program written in a programming language, to another programming language written in a different, to code that is written in another programming language, or that can help structure code, can help optimize the code in terms of how you're using the different capabilities of the language and so forth, right? There's a whole set of use cases, or let me call them small tasks, that can be offered in the Coder Turing bot. The tested Turing bot is what we're going to talk more about today. And this is not just about automation, which it can improve, but it's really more about making testing smarter, right? So, and again, when I say, AI and Gen AI, I do mean that today, thanks to generative AI, I would say even the earlier techniques of using just machine learning, deep learning, reinforcement learning, or neural networks, even the things that we were already improving since 2019 in the testing space are very, very, are becoming, let's say, reappreciated. And so things like self-healing, broken test is a specific thing that you don't really need generative AI, but that AI can support. But there's a whole, I'm going to show you quickly, and you're going to see more when Ravi goes through his presentation on Guidice, more use cases in the testing space of how generative AI can make it much better and smarter. In the delivered Turing bot, basically the delivered Turing bot is a class of agents that will help identify operational issues or help you comply with DevOps principles. Help developers comply with DevOps principles, but it's basically, what the coded Turing bot does at an application level in terms of code generation, the delivered Turing bot will do at the infrastructure level. And so basically it's code generation, infrastructure as code, helping support the operations folks in delivering software in a, again, automated but smarter way. And the dev insights that I also talked a little bit about is earlier are Turing bots that help focus on end-to-end understanding of what's happening in the pipeline, what's happening in the value stream of what you're building, are helping identify maybe where technical debt is being generated, or where value is being generated, or where there is waste. And so, and basically those are right now the 6th type of Turing bots that we see hitting the market with different levels of maturity, of course, and different level of richness of ecosystems and tools around each one of them. Now, if you look, forward out to what's going to happen over the next 5 years, the number of the classes and categories of Turing bots might change, right? Depends how this technology evolves. So today, as I said, where really the goal and perspective is about autonomous testing. And so the first thing I wanted to share with you is this data point. This is a Forrester data point of our Pulse survey on AI 2023. So it's quite recent, where you can see that when we ask our clients about which of the following development stages of the software development delivery lifecycle are you experimenting with generative AI, or in other words, with Turing bots, testing is the biggest use case, right? Which is very interesting, I'd say. And so the question then is and becomes, okay, so we've been already, working on automation over the years. Agile brought its own kind of practices that helped us change the way we were testing compared to when we were, using less agile and more waterfall type of project management. DevOps has accelerated that a bit. Machine learning, deep learning, as I said, also helped us start thinking about creating models that would help us make testing a bit more smarter and more efficient. And so the question is, what does generative AI bring in addition to everything we've been doing, right? Well, really, it's it's quite straightforward to think that generative AI will allow us to go from prompting requirements to generating code in many different languages, from requirements to and from that code generating unit tests, but from the requirements generating functional tests, right? What are the test cases that will cover those requirements? Creating a test model, if you've trained it on the models that are available out there, being able to generate instead the test case in a format of a model, or generating even a test strategy, but also optimizing and reviewing the test strategy, giving it a test case and saying, okay, here are my 20 test cases that I have for this application. Is there anything I need to optimize? Well, actually, probably if you have only 20, it's not really worth it to to get the generative AI involved. But normally you have thousands of test cases for an application. Then asking the question, can you optimize this to find out where there is duplicates or where maybe there is something missing would make more sense, right? So generating from and optimizing the functional test cases. But it can also optimize even the test strategy, right? You can test, you can generate now, because in that generative, from a generative perspective, we can generate from HTML code and other code, maybe, you know, Selenium code or Cypress or any other framework, to reverse engineer it and generate, abstract out of the code the test cases. We can go also the other way around, of course, right? From the test cases to the code, as we said earlier. Other use cases are in the area of issues and bugs remediation, right? Today, remember, generative AI is, you know, yes, it generates code, but it generates also human language. In other words, it's a very strong and powerful linguistic tool. Now, what happens is that, you know, what happens is that sometimes we are slowed down by lack of communication, of clarity and understanding. Think about a tester that reproduces a bug, that comments what the bug was and tries to write up what the issue was, right? Well, and then the developer needs to read that and has to understand exactly what the bug was about, and, you know, with all the screenshots and everything, and basically takes time to understand it and be able to fix the bug. The problem is the time is even made worse, and it takes longer when those descriptions are not clear. And I can say I've read many of these type of what as testers write, we try, you know, either make it short or don't make it very clear. But now you can ask actually ChatGPT or generative AI to better document the bugs, right? So that, and some clients have been doing this, telling me that that helps them reduce mean time to repair, right? Clarifying the language, reducing mean time to repair. That's a perfect use case when you want to leverage generative AI, because, as you know, as I said, it's a linguistic, powerful tool. But also there's the whole area of non-functional testing, security, performance. Generative AI is also going to, generative AI and machine learning, you know, this technology is also being used on how to better execute performance of performance testing, security testing, you know, making sure that the vulnerable tests that we find are not necessarily, you know, just spitting out false positives and false negatives. Therefore, again, making the tool that is scanning the code more trustful from the tester and the development and the developer perspective. And last but not least, and these are, you know, these are just a set of the use cases that I'm seeing. But another really important thing that TuringBots do, and the tester TuringBot in particular will do, is make the use of any test tool that adopts the technology easier to use, right? Or accelerators if it's a system integrator. But basically, think about now the tool that you're using empowered by a TuringBot that speaks your language, understands your language, and you can ask it to do things through that user interface. So it's changing completely the human tool interaction. And if it's a testing tool and it has this capability, then it will make your life much easier in working through with the tool, using and leveraging natural language. Natural language alone won't be enough, in my opinion. You're still going to have to, you know, use some of the modeling and other things that tool we use, but it will definitely empower you to be make a much better use of the tool. Now, that relates to the tool topic, which is, you can see that, of course, you know, if we want to automate and testing today, because of the scale, because of the number of people, because of continuous delivery, continuous integration, we need automation. And so you need tools. And only 44% of decision makers claim that they continue to lack the appropriate tool to support the test automation. This data point goes back and comes again from that study that I was talking about when we were doing the joint partnership we did on this study for digital transformation. So there's also great improvement that is needed, not just in the practices of adopting and using this technology, but also in the tools. But we predict that that expansion on the current, the limited expansion of AI in the testing organizations will change, and we're seeing that generative AI is encouraging people to actually do more with AI, do more with, we've been talking about AI for the last 5-6 years, but we haven't really seen a big pickup. And I mean, this was definitely has changed thanks to ChatGPT, because getting 100 million users on a new tool has never been anything we've seen ever in the world, right? And now there's a big example out there. So you can see that these data points will grow quite aggressively and go in the coming months, I would say, not necessarily just in the coming years. All right, so let me wrap up on what I see happening over the next 5 to 6, 8 years, let's say, right? So we're in this phase today of development teams and testing teams made mostly of humans and starting to use a little bit of automation. But the phase we are in right now is already, we're in this phase that I call TuringBots are in the loop. So in other words, we can use this technology as testers, as developers, at our convenience, right? And it's there to help us. It's there to help us do our job in a much effective, smarter way. And by 2024, as the technology matures, as generative AI matures, we're starting to build a lot of tools around it. We've all, learned things that weren't here a year ago. Nobody was talking about RAG, retrieval augmented generation years ago, 10 months ago. And now we've figured out how to make the hallucination, to keep control of hallucination, for example. So the technology will improve, and as the technology improves, so will the TuringBots improve. They will generate more accurate code. They will generate more accurate test cases and automation. They will just become better. And in other words, they will become really true peers of testers and developers in the team. So now you've got the TuringBots as peers in those teams. And 2028, and maybe the only thing I can see happening that this might be too far out, because it might happen even sooner. It depends on how things evolve. But yes, the technology will become even more autonomous. So in other words, if today we are talking about tasks and tasks that maybe, automate a process, as the technology improves again, AI becomes better at reasoning. AI becomes better at planning and setting goals, right? More autonomous, in other words, but still in the control and human supervised. Then it will become more autonomous. The technology will take off certain, big phases, big stages of work, big steps of work that we need to do, and what that means, it means that productivity will just grow, right? And while today on average, the productivity we see gain, the productivity gain is between 10 and 20% of overall software development lifecycle, which, where testing contributes maybe to 30, 40%, code generation 40 to 50%, but the other areas are still much lower. So overall, on average, 10 to 20, depending on the skills, depending on the type and complexity of the application. That's why it's an average, which will double, by 2024, and then will really truly become unimaginable, I think, in terms of the level of productivity that we will be gaining. But it's not just about productivity, it's also about creativity, it's also about happiness, with developers and testers having more fun, giving the boring work to the TuringBots and focusing more on what we really need to focus. And so basically, here, let me sum up the takeaways for this first bit of introduction before I hand it back to Ravi, right? So whether you are among the 45%, because we did ask this question also in our 4,569 business and technology professionals into our priority survey, there's 45% that are planning or experimenting, piloting or implementing with TuringBots in the next 12 months, whether you are part of that or not. And I would recommend, if you're not, you should start now. you should do the following things, right? First of all, learn by experience and share best practices among the teams. Encourage sharing and collaboration. Ask, if you start putting this technology available to your people, make sure that those that will voluntarily join the program will share what they're learning about, right? Sharing the problems, the challenges, but also, what they're getting, what they think the benefits are. It has to be clear, this is not just, all good news. In other words, there are challenges. There are challenges and risks that generative AI comes with, and they have to be, clearly spelled out to the rest of the organization and to the people to the professionals that will be using the technology. So based on the risk, that's how you can set the boundaries of where it is used, right? By leveraging in terms of the types of maybe applications that you use this, not necessarily everything that goes into production, or maybe not in an area where you've got really some distinctive intellectual property that you don't want that to be infringed by the use of the technology. And there are ways to go around that, right? Get the legal and purchasing departments involved, because again, those, some of being aware and setting the boundaries comes from legal department understanding the license and understanding exactly what the vendor will and will not provide in terms of preserving IP protection and code attribution and things like that. Select the right use cases. Generative AI comes with a cost in terms of energy, and we're becoming conscious about that, and we want to be careful, right? So let's use it for the right use cases where it's really worth it. And by the way, one important point is that, testing, I think, has a really huge role to play in all this, because as clients are using more and more those code generators, those tools that automate development, testing has to be there, right? We can't just trust the AI to do everything for us. And actually, the code generators don't necessarily generate perfect code. We need to test that code. We need to make sure it's unit tested, functional tested, security tested. And we need to develop architecture guidelines to make sure that we use the TuringBots in the right way, right? So balance the risk and measure success. So we want to, make sure that we're not just, yes, measure productivity, but let's measure also happiness of developers and other aspects of the organization. And with that, it is not AI that will replace testers, but it's testers that work with AI. You can also replace that with, it's not TuringBots that will replace testers, but it's TuringBot. But it's the testers that will use the TuringBots that will replace the testers that won't. So this is a big opportunity that I think every tester should embrace, every organization should embrace. And with that, I thank you very much, and I hand it back to Ravi.
Thank you, Diego. Your summary of the current state of software testing, TuringBots, and the future of testing was excellent. It was just spot on. In this section, I'll share some examples of what we're doing in the TuringBot space. And I think, like I said earlier, we'll discuss a case study while maintaining client anonymity. But most of all, I'm going to try to touch on some key points that you made. And I think your views about requirements, your views about design and testing are exactly what we're seeing. And I'll address them from our point of view, at least from the standpoint of how we're developing TuringBots for Guidice and how we're deploying them for our clients. I'm going to show some of my slides, which hopefully will sort of, provide greater heft to what is happening in the market. Will provide some additional focus to all the things that you've been talking about. And Diego, can you see my screen? I just want to make sure that you're able to see the screen.
Yep.
Perfect. So, obviously, up to this point, we've talked about, what the market trends are. And, my role in the next 20 minutes or so would be to sort of take some examples, take some of our case studies, and try to sort of put them in an anonymized manner so that our audience can get a sense for where is the technology today, how is it going to work for all of us. And, most of all for me, I think I should want to start with, what is our definition of TuringBots? What is a Guidice definition of TuringBots? From our standpoint, it's very straightforward. You've already described TuringBots. From our standpoint, the Guidice sense is that these are algorithms that have a very distinct or singular purpose. We also refer to them as single-use agents. And when various single-use agents come together, or when we can combine single-use agents or TuringBots, they're designed to perform a very specific set of tasks or achieve a very certain or a certain set of testing objectives. So these examples could include generating test scenarios. They could include amplifying data. It could be sort of getting a much finer understanding of domain so that you can deploy that in different points or different points of view from a testing point of view, rather. But most of all, if we go back to some of the things that you said, you spoke about requirements, you spoke about design, you spoke about tester bots. These are all the areas that we're also trying to address. So if the Turing bot is essentially an algorithm with a very distinct purpose, and we call them single-use agents, the question then is, sort of this fundamental question about Turing bots or SUAs are, can they find bugs faster? Can they reduce manual effort? Can they improve test coverage? Can we learn from experience and recommend things? Can we analyze logs and identify issues? Can we use maybe Jira tickets to develop tests? Can we use natural language to create perhaps API mocks? All of this happening in the early process. Can we do just a number of other things early in that design phase, early in that requirements phase, so that to the point that you are making, the life of the tester becomes so much more easier. Right? If these are the asks, if these are the objectives, then, and to answer that fundamental question, it's a very simple yes. Right? I mean, from our standpoint, there are 2 or 3 key things that you have to think about when you think about Guidice. Right? First off, it is a SaaS platform. It ships with all the necessary features for software, functional, and some non-functional test automation. So everything that you see on the left-hand side of the screen sort of captures all the essential things that Guidice does, from a testing standpoint or from a test automation standpoint. It also ships with infrastructure, whether it's browser farms or whether it is device farms and so forth. But importantly, for the topic at hand today, it's the things on the right-hand side that become really important, right? So the platform ships with a slew of generative and ML agents that are designed to make software testing simple, designed to make software testing more intelligent and scalable. And these are designed with multiple personas in mind, whether they're testers, whether they're SDETs, developers, or business experts, right? So, but the fundamental question is, we can take these single-use agents, we can deploy them in ways in which each of these personas get a tremendous amount of benefit. Now, for simplicity, what we've also done is we said that, can we look at these Turing bots from the standpoint of the SDLC? So for simplicity, we've taken a very iterative, development model and we sort of put it out in a very linear fashion with the idea of showing you where we've developed and deployed Turing bots, from the standpoint of different phases of the SDLC, right? So as an example, this visual captures, Turing bots by phase, and beyond the number, the main takeaway is the concentration of these bots across the SDLC. They're designed to impact every phase of the development cycle. So while the testing phase is obvious, we have a concentration of solutions in the design and build phase. And this goes back to the point that you were making earlier in your presentation. And we like to look at this concept beyond the traditional motivations of even shift-left testing. And what I mean by that is, yes, we want to find bugs early in the process. We want to reduce cost and we want greater visibility all early in the process. But by deploying these Turing bots, we can actually go to this thing called a point of origin testing. Right? And what that means is, in the pre-design phase, in the design phase, in the requirements phase, and in the build phase, we can deploy these agents where they do a number of things that can impact the cost and efficiency of testing, right? So just a quick examples here. In the design phase, we can deploy something called Nova, and we'll talk about this in a little bit more detail in the coming slides. But the idea is to take design screens by integrating with Figma and developing testing scenarios at that point in time. In other words, at that early requirements, early design phase, we can take input from design palettes and start designing our tests. If you have to the point that you made about HTML, I mean, if there are early mock-ups of a website, we can take that information and start designing testing scenarios early in the process using Test Pilot. Now, what that means is as this web deployment becomes more mature, as it goes through its iterations, we can also iterate with our testing scenarios and the test scripts. Right? And then when it comes to domain understanding, whether it's capital markets, like a Calypso implementation or an SAP implementation, we now have the ability to sort of take context, take domain capabilities, understand domain at a very nuanced level, and use that information to sort of start creating testing scenarios, right? Again, all of this happens in that early design phase. And we can use something called test scores to start generating unit tests. And this happens through integration with VS Code. And finally, in the design phase, again, we have this solution called Nova that will integrate with Jira and take Jira issues or Jira stories. In other words, it can take requirements at that, again, early stage and start designing testing scenarios using that information. And as you progress through this, through the SDLC, whether you have to amplify data using a Turing bot, or to a point that you made about converting tests, right? Whether if something's been deployed in Selenium and you now want to automate and you want to convert that, we can use the test converter. So to many of the points that you made in your presentation, Diego, we've been able to deploy these agents or these Turing bots for each phase of the SDLC to make testing better, faster, smarter. Right? So now, in the context of today's conversation, there are a number of things that we wanted to show, but we're just going to summarize this by saying that let's focus on requirements and let's maybe focus on API. Right? So over the course of the next few minutes, I'm going to take a banking case study and I'm going to sort of anonymize that. And we're going to demonstrate how to generate web application testing scenarios and mock APIs in the requirements phase. In other words, when nothing's been coded, not a stitch of code has been written, how do you start generating testing scenarios so that the tester or the business analyst can sort of get ahead of their day and actually use these Turing bots as agents that can support them. Right? So we're going to use this using Nova, which I've mentioned very briefly. So Nova is designed to read Jira issues or stories and generate testing scenarios. And then of course we can bring that into the main Guidice modules and automate it. And then we'll also talk about Vision Nova, which is essentially an algorithm that will analyze an image. In this case, we'll integrate it to Figma and again generate testing scenarios. And finally, we will use the API builder, which is the other Turing bot that'll generate all applicable API tests for that same scenario. So in the process of anonymizing this case study, we've converted a banking application into sort of a student loan management solution, so that we've made some subtle changes that protect the privacy of our clients. But essentially, what you see on this, on this screen right now, is a recording of these three Turing bots working together, or in this case, two of them can work in parallel. They can also work in sequence. It just depends on how you want to deploy these bots. But we'll show you these three distinct Turing bots essentially generating testing scenarios for the student loan management portal, right? But the basic idea here is that a student can log into this portal. They can apply for or manage or repay their student loans, and the features of the platform include things like how do you upload a document, how do you track your loan, and what's the repayment schedule, and so forth. And the key thing to remember is the issue ID is MON4, And then this is a screenshot from Figma. So for the applicable student loan portal, this is the design that was developed. And now the question is, how do you make all of these things work together, right? So the first TuringBot that we will take is called Nova Vision. And essentially you have to provide it some metadata information, like provide it the access token, provided the URL, provided a project name. In this case, the project name is Team Project. And then you have to give it a specific frame that you wanted to go find and start generating tests, right? So in this case, the frame is called Quantum Financial Trust. And once you provide all of this information and simply hit Generate Test, the bot goes out and starts pulling up all the information that you would need in order to generate testing scenarios, right? So in this case, it'll find information, it'll provide a description, it'll identify an objective. In the first scenario, it sort of goes out there and looks for mandatory data tests, mandatory fields that are part of the test. It looked for invalid data. It'll give you ideas for how you would check error messages and so forth. And then in the second scenario, which we've highlighted there, it's going to look for a specific date format and so on, right? So it generates a number of scenarios like this. And then once you have that information, you can use the same bot to also verify accessibility, right? So in the case of accessibility, it's going to go out and look for things like text size and readability. It looked for color, it looked for text spacing, and so forth. But the key point is this Vision Nova immediately, generates this kind of information for you, right? So if that was the first one, the second one is deploying the API builder, right? Now the API builder took some very basic prompts from us again, from that same Jira document or Jira output. And what it does is, once it gets that basic description about the project at hand, it essentially goes out and starts generating all the things that you would need for API testing, right? In this instance, it'll generate a Swagger JSON. It also shows the API definition. It addresses all the verbs that you could think about as far as this deployment is concerned. It pulls up sample values. It generates the schema. And then finally, that JSON imported into the Guidice API module, from where you can start generating, doing the kind of test automation that you would need, right? So that was the second TuringBot, right? So we talked about the Vision TuringBot, which does which takes a visual input and generates testing scenarios. And the second one is it takes basic description of the required APIs for that same transaction, and it generates all the necessary API steps, and then you're able to download that document as well. Right? The final one is the TuringBot, which will now integrate directly with your Jira environment. This is called Nova. And what Nova does is it takes information directly from Jira. It takes that ticket, that M014 that we identified on that first screen. And once it has that information, it'll automatically start generating testing scenarios, right? So whether it's verifying the loan tracking process or verifying the repayment process, whether it's verifying the user registration, all that information is immediately generated, and that information is then imported into Guidice. So now you've closed the entire loop, right? So you've now essentially gone through multiple TuringBots, whether it's visual or direct integration with Jira, or generating mock APIs. You've created all that output, all through the simple clicks of a button, and then you've imported that into Guidice, and then you're then able to start generating tests, right? So for example, in this scenario, you can see that the first test scenario is about verifying the user registration. It then looks at verifying the document. It then looks at verifying the loan tracking process, managing schedule. It also integrates with university systems and banks and gives you appropriate tests for that. And this is where the API testing, the mocks that we generated become more relevant. And again, the key point that I'm trying to make is that, in order to generate these tests, we did not go into Guidice, we did not go into the platform, and we didn't start clicking around, trying to find fields or trying to manually create tests or record tests. We just gave the TuringBots very simple input. Right? It takes that input, it generates the tests. It's all in Guidice now, automatically uploaded. And of course, now you can go in and fine tune it. Right? But beyond fine tuning it, what you can also do is continue to use it as your application matures. As it goes through its iterations, you can start using the same tests, or you could run these TuringBots again, get a better set of tests, and that becomes the new way of testing, right? So, I mean, and that's the fundamental point of all of these things, of this entire conversation. What is a new way of testing? Right? From our standpoint, this is the future, and that's the point that you were trying to make as well, Diego, right? So, just to go through this, quickly, this is again the Jira screen where you're taking input from basic requirements documents. You then go to Guidice Vision Nova. You integrate it with Figma. You find the project. You upload the direct frames, and all of this happens instantaneously. This generates your testing scenarios. It also generates accessibility information. So you've got both those things done in one shot. Then you can go to the API builder, provide it very similar information. It generates all the verbs, all the requirements for API testing. Once you have that information, you can then export that to Guidice. And once you have it in Guidice, you can start running those tests. And then finally, we can also run the entire testing from an AI standpoint and say, Guidice, I just want you to integrate directly with Jira, get the information, get the requirements from Jira, run the testing scenarios, convert the scenarios into test scripts, import it into Guidice, and you're off to the races. Right? So from our standpoint, that's the new way of testing. Our definition of TuringBots, again, is these algorithms that you can deploy as single-use agents, or you can bring them all together and sort of deploy an army of these agents, an amalgamation of these agents. And what we're seeing based on some of the work that we've been doing thus far is that, number one, it's changing the nature of testing. Number two, there are just a number of efficiencies you can expect. We're seeing anywhere from 40 to 50% reduction in costs, but there's also this corresponding efficiency that comes with these types of deployments, and those are the sort of points that you were making early in your conversation as well, Diego, about deploying these TuringBots as assistants to the developer or the tester. And then the question, therefore, is how does that change testing? I mean, what is the future of testing? And from your standpoint, you talk about this 5-year and 8-year timeline. We think that's very consistent. We've been able to deploy some of the things that that I think you're going to see mature even more in 2024. And then what happens in 25 and 26 is really to be determined, because the change is happening at an enormous pace right now. So anyway, for the audience, there was a sort of a rush demo, there's a lot of information compiled into about 10 or 15 minutes. But we want to just leave you with that high-level information so that you can then, if you're interested, you can sign up and you can start testing at Guidice.com. If you have questions, you can send it our way as well. So,
yeah. So Ravi, just one thing. I guess the point about the how fast this will mature, right? I guess on one side, what you're saying is perfectly coherent with the fact that looking at the technology side of things, right? Now, technology is evolving really fast. What I'm seeing is that it's the adoption rate of clients that is slower, right? So whatever we are developing will have to also kind of meet the pace of clients, which I think will increase with generative AI, because we are making things simpler. And so that's why I kind of see this trajectory going over the next, 2, then 4 to 6 years. And that's the reason why, because it's just, we have to look at both sides. The technology is maturing faster than the time at which clients have been absorbing, adopting, and making change.
Right. I mean, I think those are very valid points, Diego. In fact, one of the things that we're debating is, how do we start testing now? Should we start with AI, or should we start with what is suddenly a traditional way of developing automation scripts and then deploying AI to make it better or to improve the process? And we're figuring that out. And in fact, in my very short demo, you'd have noticed that when I used the Figma interface or Vision Nova, we went directly from the AI point of view, and we said just integrate with Figma, get the image down, and then start generating testing scenarios. Whereas on the last screen where we integrate with Jira, we're providing the user more options. The question is, do you want to start with AI, or do you want to start with a more traditional way, and then do you want to compare and contrast? And those are things that we have to decide as well. From a pure UI standpoint or even a UX standpoint, we're now trying to figure out exactly the point that you made, which is that we have the tech. We know how to make this work from a automation standpoint, from an AI standpoint, but what is the best way to make it available to the end user, right? I mean, and those are some things that we're trying to figure out. But Diego, that's as much as I had for today. If you would like to close this with any of your comments, that'll be fantastic.
No, I think that the time is now. People should really take a close look at this. The technology is there. Basically finding how to consume this is just by trying it out and doing it. I think you have to. This has to be really. Yes, top down is fine, but it has to be bottom up, right? Give it to the people on the ground. They will figure out what are the best way. We're all learning, right? We're learning the best practices, and we as Forrester, our job is to try to kind of formalize some of these things and share them with you. But I think it really is time to accelerate a bit on adopting AI for testing.
Perfect. Diego, once again, thank you very much for working with us on this very important topic. I mean, there's a lot to learn from you, and we appreciate your time. Thank you, and take care.
Thank you for having me. Thank you. Bye-bye.